Exercise 11, Coordinate Geometry, Coordinate Methods in Geometry. Question 1. From the point A, 3, 4, a line is drawn such that this perpendicular to the line 2x plus 5y minus 10 equals 0. L intersects the line x equals 1 at B. What are the coordinates of B? Okay, now just pause the video. Okay, now here is the solutions to it. I'm going to be very careful when we're plotting these points. So I'm going to plot the point 3, 4. 1, 2, 3, 1, 2, 3, 4. There's A, 3, 4. And the line 2x plus 5y equals 10. So when x equals 0, y is equal to 2. So there's 0, 2 there. And of course, when y equals 0, x equals 5. Let's move this up a bit. There we go. 5, 0. So there's my line. Different colour. Let's do it like this. Okay, and we also got the other line x equals 1. We'll make that say x equals 1 here. X equals 1. And our line, which is perpendicular, right, goes through here. Coming through here. There's the point of intersection there, and that's L. That's a right angle there. So clearly we need to find the equation of the line L. Now to do that, we can just, because it's at right angles, I can swap these guys over and write that as 5x minus 2y equals some constant k. Now the point 3, 4 lies on this, so I can put 3 in there for the x. It's 15 minus 8 equals k, so k equals 7. So we have the equation of L is 5x minus 2y equals 7. That is L. But we know that x equals 1 lies on it, so put 1 in there for x, so 5 minus 2y equals 7, minus 2y equals 2, y equals negative 1. So that's the point 1, negative 1 are the coordinates of B. Right, number 2, the points A, 2, 6, B, 4, 8, C, 6, 2, and the origin O are the vertices of a quadrilateral. P is the midpoint of OA, Q is the midpoint of AB, R is the midpoint of BC, and T is the midpoint of CO. Show that PQRT is a parallelogram. Right, so just pause the video, draw up that diagram. Remember, try and keep the scale the same on both axes. And see if you can prove that. Alright, here we go. Now we've got 2, 4, 6. Okay, so we go 6 across and we've got to go 8 up, haven't we? 8 is the highest one. Alright, so look at this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we have A is 2, 6. 1, 2, 3, 4, 5, 6. A is there. 2, 6. And we have B is 4, 8. 1, 2, 3, 4. Up here. There's B, which is 4, 8. And we have C, which is the point 6, 2. 6 up to 2. Okay. This is not too good, is it? That's alright, that's okay. There we go, there's the origin. Sorry, I was thinking it was a parallelogram for a tick. Okay, that's what we're going to prove. Okay, so C is the point. 6, 2, that's good. 6, 2, so that looks like any sort of a... Here we go, that's good. There we go, 2, 6 like that. And there, okay. Rightio. Now this is very interesting because this happens with any quadrilateral. You'll form a parallelogram if you just join the midpoints. So we've got to find the midpoint of P. P is the midpoint of OA. So that point there, P, is going to be adding them together and dividing by 2, 1, 3. Okay, the other one up here, Q. Q is the midpoint of AB, which is 3, 7. And this one over here, R, has the coordinates 5, 5. And down here, T, has the coordinates 3, 1. Okay. Now that should look a bit like my diagram's not too good though, is it? Okay, so we've got 2, 6, sorry, here. Okay. The better diagram you draw, more nicely this will come out. I'll just draw it in a different colour. So I'm going to draw that. There's the midpoints there. That's the one there. Okay, here we go. There we go there. There we go there. That's not too bad, considering my wonky old diagram. So yeah, it's pretty good, isn't it? Got to prove it though. Alright, now to prove it, well, I'm just going to go, I'm just looking at the gradients. It's probably the easiest way. You can do distance and gradient, but I'm just going to go for the gradients. The gradient of PQ, this is PQ, this one up here, this one here, PQ, gradient of PQ is going to be equal to 7 take away 3 over 3 take away 1, and that's just going to be 2, so gradient that one is 2. Now the gradient of RT, okay, is going to be 5 take away 1 over 5 take away 3, which again is going to be equal to 2. So we've got these two guys parallel. Now the gradient of PR is 7 take away 5 over 5 take away 3. Sorry, it's 3 take away 5. 3 take away 5, which is 2 over negative 2, which is negative 1. Now the gradient of PT is 3 take away 1 over 1 take away 3, which is 2 on negative 2, which again is negative 1. So these guys here are both parallel as well. Therefore, PQRT is a parallelogram. And as I said before, take any quadrilateral and join the midpoints, then the figure so formed is a parallelogram. And you can actually prove this with general points. It's a bit of an effort, but it's the same sort of principle.